Good morning to all of you. Myself, Professor N.V. Arpe from SND College of Engineering and Research Center, Yeola, working as a assistant professor in Electrical Engineering Department. So today we will start the new topic, that is strain gauge of subject of the course, that is electrical measurement and instrumentation. What is strain? What is strain? Strain is the amount of deformation due to an applied force. Amount of deformation due to the applied force means to change in the length, to change in the length due to the force applied on the any any material. More especially, the strain is defined as the fractional change in length. Fractional change in length when the due to the force applied. Due to the force applied, strain can be negative or positive, compressive or tensile, whereas dimensionless strain sometimes expressed in units such as in inch per inch or mm per mm. Means the strain of any object, the strain on the any object, which will be negative. It can be negative or positive. Means it can be compressive. If the strain is negative, then we can say that this is compressive. If the strain is positive, then we can say that it is tensile. And it is dimensionless strain. It is dimensionless because the unit is in such that such as inch per inch or per it will be cancelled, and it means that the strain is unitless. In practice, the magnitude of strain is very small, therefore it is expressed in micro strain. This is the diagram to showing the strain. When the force is applied, force is 2 hours away from this, then the length will be increased. That is delta L. And this is error is equal to delta L upon L. What is strain gauge? A strain gauge is a device used to measure strain on an object. For measuring the strain, we use the strain gauge. For measuring the strain on any object, you can use strain gauge. It is also termed as load cell. It is also called strain gauge is also called as load cell. The most common type of strain gauge consists of an insulating flexible backing which supports the metallic foil pattern. Metallic foil pattern. This is the type of strain gauge having insulation flexible. Strain gauge consists of insulating flexible backing for the supporting of metallic foil pattern. This is your strain gauge. This is metallic strain gauge. Again, this is again strain gauge. This is an object. This is an object having the tension. Strain gauge. This is compression and this is compression. This is tension. This is compression. Tension means the force will be away, and due to that, it will be expand the length. And if the force is towards the object from both the sides, then it will be compressed. Then the object will be compressed. As the length increases, the resistance increases of that. According to the formula, resistance is equal to rho L by it is R is directly proportional to L. Resistance is directly proportional to the length. And resistance R is equal to resistance. Rho is the property of material, that is the resistivity of material. L is length of wire and A is the cross-sectional area of wire. In that, as the length is decreases, the resistance of that material of that object is be decreases. Means according to the change in length, the value of resistance will be changes, and according to that, we can measure the strain. We can measure the strain. The strain gauge applications for the measurement of pressure, for measurement of force, for measurement of small displacement, measurement of torque, and measurement of load, etc. This is the application of strain gauge. This will be shown in that figure also. This is applied for pressure. It will be measured by using diaphragm strain gauge. It is your force. Force. This will be measured by using strain gauge. This is your weight. Weight. This will be measured by using strain gauge. This is your application. The principle, the working principle of strain gauge is, if a metal conductor is stretched or compressed, its resistance changes on account of the fact that both length and diameter of the conductor changes. Both the length and diameter of the conductor will be changes. Means if the conductor is stretched and it is compressed, this material is stretched, its resistance changes on the account of fact that both the length and diameter of the conductor changes. Means if it will be stretched from that point, then the length of the length is changes, that is delta L, and diameter is also changes, that is delta D. And according to the resistance formula, R is equal to L rho L by A. It's the resistance of unstretched conductor. This is the resistance of that conductor. But we can find the resistance of that conductor after the stretching. After the stretching, this is the force. It will be applied on that object for the stretching. And after the stretching, the resistance value is R is equal to rho L by A. The L is L plus delta L. Let the tensile strength yes applied to the wire, that wire, with result change in length delta L, change in area is delta A. This is change in diameter is delta D. In order to find delta R, R is differentiated with respect to stress, that is yes. And dr by ds is equal to rho by A, d by s by d by L by d by s, d by L by d by s minus rho into L divided by A square d by A by d by s plus L by A d by P by d by s. This is the equation after the stretching. Dividing equation 2 with the equation 1, then 1 by R dr by ds is equal to 1 by L, rho A get cancelled, 1 by L d by L by d by s minus 1 by A, rho L by A is cancelled, then 1 by A d by A by d by s plus L by A get cancelled, then 1 by rho d by P by d by s. From this equation 3, the unit change in resistance is due to area, that is A, per unit change in length delta L by L, B, and the per unit change in area, that is the it means the resistance value changes according to the change in length, that is delta L by delta L by L. Second is per unit change in area, delta A by A, and again per unit change in resistivity, that is delta del by A, or delta rho by rho. This is your the value, change in value. According to that, the resistance of the material will be changes. A is, what is A is pi by 4 d square. Del by A by del by S, then 2 into pi by 4d, 2 into pi by 4d. The area is pi by 4d square. Del by A by del by S is 2 pi by 4 into d, del by d by del by S. So dividing both sides by A, then 1 by A dA by ds is equal to 2 pi by 4 by d upon pi by 4 d square into d by d by s. d dd get cancel, 1 upon d, pi by 4 get cancel, means 2 by d by d by s. Then 1 upon r, from this previous slide, 1 by r dr by ds is equal to 1 by l by l by s minus 1 by a by s plus 1 by rho by p by s. Then 1 by r, 1 by a dA by ds is equal to, put this value, 2 by d by d by s, and remaining equation are same. Then now positions ratio is V is equal to lateral strain upon longitudinal strain, that is minus d by d upon d by l by l. Then d by d is equal to minus V into d by l by d, putting equation 7 in that equation 6, that is d by d. Then 2 by d by s is common, 2 by 2 upon d by s common, then minus minus plus d by l by l. All for all variation above, we can be written as delta L r by r is equal to delta L by L plus 2V delta L by L plus delta P by P. So delta rho by rho. Then GF is equal to delta R by R upon delta L by L. Then strain is equal to delta L upon L. Then gauge factor, it is defined as the ratio of per unit change in resistance to the per unit length. That is d by R by R is equal to GF, d by L by L is equal to GF into E. Then the gauge factor is 1 plus 2V plus delta rho by rho upon E epsilon, or 1 plus 2V plus delta P by delta rho by rho upon delta L by L. Also gauge factor is equal to 1 plus 2V as the strain in terms of micro strain. Then the gauge factor is equal to 1 plus 2V is valid only when piezoelectric effect, piezoresistive effect, that is change in resistivity due to the strain is almost negligible. For metal, Poisson's ratio is between 0 to 0.5. For material nickel, the gauge factor is minus 12.1. For manganese, plus 0.47, nichrome plus 2.0, constantron plus 2.1, soft iron plus 4.2, platinum plus 4.8, carbon plus 20. This is your introduction of strain gauge. Now in next lecture We will see the problems on the strain gauge factor and types of strain gauge. So stop here. Thank you.